Limit as z goes to 1 of the square root of 1 over z minus 1 all over 5 minus 4z minus z squared. The first thing we're going to do is try plugging a 1 in for each of the z's. That'll give us the square root of 1 over 1 minus 1 over 5 minus 4 times 1 minus 1 squared. The numerator, 1 divided by 1 is 1, out of the square root, minus 1. The denominator, 5 minus 4 times a 1 is minus 4, and minus of 1 squared is minus 1. Square root of 1 is 1, minus 1. 5 minus 4 is 1, minus 1. 1 minus 1 is 0, 1 minus 1 is 0. We have the 0 over 0 indeterminate form. We will need to rework this. Since we have a root combination, a root involving the variable z in some way, added or subtracted together with at least one other term, that's happening in the numerator. We can try the root conjugate method. So I'm going to rewrite the limit exactly as we see it. And we're going to form the root conjugate, which is the same terms in the root combination but opposite sign between them. I'm going to put that over itself so we have a form of 1, so that when we go and multiply with the original, we do not change the value, just the look. In the numerator we have a root conjugate pair. We are going to FOIL that out. First, root of 1 over z times root of 1 over z will be 1 over z. Outside, root of 1 over z times a positive 1 is a positive root of 1 over z. Inside, negative 1 times the root of 1 over z is negative root of 1 over z. And then last, negative 1 times a positive 1 is a negative 1. The outside and inside terms of a root conjugate foiling are always equal value, opposite sign, and we'll be able to cancel. In the denominator, we do not have a root conjugate pair, so we are not going to FOIL this out. They are multiplying each other, so we're going to continue to keep them multiplying each other, but keep them in a factored form. Now, the root conjugate does not remove the 0 over 0 indeterminate form, but it puts it into another form that can be worked with. I will rewrite what we have left right now so we can decide how to rework this. So we are still going to have 0 over 0, and the numerator the 0 is happening here, and the denominator the 0 is happening here. Since the numerator 0 is happening because of a fraction, our next step is to deal with the fraction form, which would be a common denominator method. So we're going to get a common denominator between the two terms in the numerator. I'm going to multiply that 1 by a z over a z so that we form the common denominator of those two terms in the numerator. That will give us a 1 over z minus a z over z, and that will be all over that same denominator, 5 minus 4z minus z squared, and then the square root of 1 over z plus 1. We can now combine together the terms in the numerator over their common denominator, 1 minus z over the common denominator of z, and all of this divided by that same denominator. Our next step is to reciprocate the denominator and multiply it. So we're going to put everything over 1 here so that we can reciprocate and multiply. We need a fraction in the denominator to be able to do that. So by putting that over 1, I now have a fraction. So we're going to have 1 minus z divided by z multiplied with 1 over, so we reciprocate the denominator, which means the 1 moves to its numerator, and everything else moves to its denominator. Now we actually multiply those together, and we have the limit as z goes to 1 of 1 minus z divided by z times 5 minus 4z minus z squared, and then square root of 1 over z plus 1. After having done the common denominator method, we've now turned this into power functions. We're getting a 0 in the numerator because of this, and we're getting a 0 in the denominator because of this. So these will need to be factored so that we can cancel out the common factor that is making the 0 over 0. Z is going to 1, so the factor will be either 1 minus z or z minus 1. It's probably best to factor a negative out of both the numerator and denominator. The numerator so that we get a z minus 1, and the denominator so that we can trinomial factor it. I need to take the negative out so the z squared term becomes positive. That will also make the 4z become positive and the 5 become a negative. Okay, at this point, our next step, we're going to trinomial factor the denominator. So in the numerator we have negative z minus 1. And then in the denominator we have a negative, we have a z. And we can trinomial factor. We need two numbers that multiply to be a negative 5 and add to be a positive 4. It sounds like that would be a positive 5 and a negative 1. And then let's not forget our other root expression. There's the z minus 1 in the numerator and denominator that can be canceled. That will leave a 1 here in the numerator. So I have limit as z goes to 1 of, well, let's cancel the negatives out here as well, since I have 1 in the numerator and denominator. Positive 1 divided by z times z plus 5 times the square root of 1 over z plus 1. We can now try plugging a 1 in for each of the z's. We've removed the 0 over 0 factor. 1 over 1 times 1 plus 5 times the square root of 1 over 1 plus 1, which will give us 1 divided by 1 times 6. The square root of 1 is 1, 1 plus 1. 1 divided by 1 times 6 is a 6, and then 1 plus 1 is a 2. And that gives us 1 over 12.